Hello my dear students, good afternoon, hope you all safe. Previously we discussed about some concentration terms. In that last we discussed molality, which is very important for us. So what exactly molality means? The number of moles of solute present in 1 kg of given solvent. So this is very important. So just recapping few things like what exactly molality means. The number of moles of solute present in 1 kg. This 1 kg of given solvent is called molality. Molarity means the number of moles of solute present in 1 liter of given solution. That is molarity. So molality, you have formula, that is weight of solute by gram molecular weight of solute into 1000 by weight of solvent. Correct? 1000 by this weight of solvent in grams. So all these things you must remember. Suppose here 1 m given means 1 molality meaning. 1 capital M given means 1 molarity meaning. What is capital M? Don't ask me again. 1 m means 1 molar solution. 1 molal. This is called molal solution. This is called molar solution. That is the difference. Okay, so don't get confused. So 1 m given, 0.5 given. So those all things you know already, like what is molar, what is semimolar, decimolar, centimolar. Those are all formulas. So here I'll give you few more things like what is the relation between molarity and molality. Relation between molality and molarity. So take relation directly. So we can use that relation, and by using that relation you can have some numericals. Okay, so what is the relation between this molarity and molality? Let's see. So molality I'll take, but generally I'll give direct what is exactly formula here. Okay, so later on in 12th standard, that means second PU, you will have a derivation like that. Okay, so now just simply remember formula. Molality is equals to molarity into 1000 by density into 1000. What is D means here? Density. Density into 1000 minus m into molecular weight of solute. Molecular weight of who? That solute. Okay. So this is molality formula, an important relation. You must know this one. What is small m here? Small m means molality. Okay. What is capital M here? This capital M means molarity. Okay. So this is the relation between molality and molarity. So what is D here? D. D means density. Whose density? That is density of solution. Okay. So they will provide. You have no need to worry. So if density given and this molarity given, so what is molality? If they are asking, you have to use this formula. So simply remember everyone. So relation between molarity and molality, in that molality is equals to molarity into 1000 by density into 1000 minus molarity into molecular weight of solute. So this is very important relation for us. So okay, if density given, so like that you can solve numericals here. Okay, suppose what is molarity, or calculate, example I am giving, calculate molality, calculate what? Molality of 0.1 m. 0.1 m. What is the small m means? Okay, molality given. Capital M means what given? Molarity given. Don't get confused. So calculate molality. So small m asking. So okay, 0.1 capital M. Sorry, because asking molality. So asking what? Asking what, sir? Small m asking. Given capital M means molarity given. What is m value? Don't ask me. That molarity value is 0.1. Don't get confused. So calculate molarity of 0.1 m H2SO4 solution having 1 gram per cc density given 1 gram per cc, what given? Density given. Okay, so who is the solute here? Sulfuric acid is the solute. Okay, so what we have to do now? So molality. So calculate molality of 0.1 m, capital M. So what given? Molarity was given. 0.1 means what is the 0.1 capital M means what given? Molarity given. What asking? Molarity is what? Okay. So now molarity is equals to, just here only you have formula. So molarity is 0.1 into 1000 by density how much? 1. 1 into 1000 minus this one how much? Molarity again 0.1. Molarity 0.1 given. So molecular weight how much? 98. So molality is equals to 100 by, it is 1000 minus 9.8. Okay, because 1000 into 0.1. So 0.1 means 1 by 10. So 1000 by 10. So 100 by 1000 minus 9.8. Got it? So if you simplify, you will get molality formula. Sorry, value. What is molality you will have here? So got it? So this is the relation between molarity and molality, like this you will have. So have a look and just write down all these things. Okay, so this you know already, this formula and the numerical write down. Okay, thank you. And now we will discuss about one more important now let's see about one more concentration term, which is called mole fraction, represent with x, or we call xi. Okay, so here what exactly mole fraction? In previous we discussed molality, normality, all have some units. See, molarity you have, what is that units? Mole per liter. Normality means what? Number of gram equivalents per liter, like this you have. And molality means here you have moles per kg or moles per grams, here mole per liter or mole per cc, like that you have. And this molarity and normality are temperature dependent. Why temperature dependent? Because molarity means mole per liter, because molarity means what? Number of moles by volume. So here volume term you have, right? So temperature if changes, volume will change. If temperature increases, volume increases. Certainly this molarity and normality will change, because in normality also number of gram equals by volume. So molarity and normality are temperature dependence. Getting? So here why they are temperature dependent means temperature increase, this molarity and normality will decrease. Why? Volume increase. Because volumes are in denominator or not? Tell me. Getting what I am saying? So like that. So temperature if changes, then molarity and normality will change. So simply remember this one. And molality, it is temperature independent. Temperature independent. Who is independent on temperature? Means who won't depend on temperature means molality. Molality will not depending on this temperature, because there is no volume here. See, what is molality formula? You know everyone. What is molality means? Molality is equals to moles by weight. Weight of who? That solvent. Weight of solvent. So in molality there is no volume term. So even you are changing temperature, here volume term is not there. So no difference in molality value. Certainly molality is temperature independent. And one more thing, Now I just given that mole fraction. Actually mole fraction definition I was not given, but these four comparison are very important. And for mole fraction, no units. In that name only you have moles fraction, means fraction of moles. So no units. At the same time, this is also temperature independent. So these four things are very important. Please remember molarity units, normality, molality and mole fraction. These all are very important, and these two are temperature dependent and these two are temperature independent. They are dependent, these two are independent. Reason also I was given clearly. Okay, so just go through that. It's very important. Now I'll give you what exactly this mole fraction. Okay, so mole fraction. Actually, in a solution, there are two components or more than two components you will have, correct? So for a particular component, that component supposed to say that is solute. Solute mole fraction if asking. So what is the mole fraction of solute means number of moles of particular solute by total number of moles of both solute and solvent. Getting what I am saying? Suppose solution consists of solute and solvent. What is the mole fraction of solute? If anybody asks you, then mole fraction of solute is equals to number of moles of solute by number of moles of solute plus number of moles of solvent. Getting? So in that way you can say in general, if solution consists more than one component, if suppose you can assume like A, B, C are three components in solution. In solution, how many components are there? Three components. Then what I can say for mole fraction of this particular A? Here I written A means this is the mole fraction of A. What is mole fraction of A? Means here you can say number of moles of A by total number of moles. Total number of moles of all components. This is mole fraction of A. If three components are present. What is mole fraction of A? Simply number of moles of A by total number of moles of all components. So in generally, what is mole fraction? Means it is a ratio. It is what? Ratio of number of moles. What's that? It is ratio of number of moles of one component to the total number of moles of all components. This is what exactly mole fraction. So mole fraction means what exactly mole fraction? It is a ratio of number of moles of one component to the total number of moles of all components. This is called mole fraction. Got it, sir, clearly? So mole fraction means exactly if these three components are there, A, B, C are three components, then what exactly mole fraction of A? Suppose A has number of moles Na and B has number of moles Nb and C has number of moles Nc. What these are? Na, Nb, Nc are what? Number of moles. For A, number of moles Na. For B, number of moles Nb. For C, number of moles Nc. Then what exactly mole fraction of A? Means number of moles of A by number of moles of A plus, number of moles of B plus, number of moles of C. This is mole fraction of A. Moles fraction. Whose fraction it is? A fraction. Okay. How many moles of A given and how many moles of B given, how many moles of C given, you must know. At least you must know weights, because number of moles formula, you know. What is the number of moles? This is weight of substance by gram molecular weight of substance. You know, mole means 1 mole is equals to Avogadro number. 1 mole means 22.4 liters. 1 mole means gram molecular weight, like that. 1 mole, if it is 1, weight is equals to gram molecular weight. Getting what I am saying? So N means, you know, at least to have mole fraction, at least you must know weight of a solute. Certainly, weight of a certain component. So then you can have a number of moles, like that. So number of moles is equals to weight of substance by gram molecular weight of the same substance. Got it clearly? So mole fraction of A is equals to Na by Na plus Nb plus Nc. What is Na? What is Nb? What is Nc? Here I was given. Na means number of moles of A, number of moles of B, number of moles of C. See the definition now, it's correct or not? Tell me. It is the ratio of number of moles of one component, number of moles of one component to the total number of moles of all components. Total moles, because a solution consists of 3 components. I am assuming 3. You can have 2, like that. Suddenly it's correct. Our assumption, but in numerical what they given, we must consider in this. Suppose one is HCl given, one is H2SO4 given, one is HNO3 given. So 3 substances moles you have to consider. Whose mole fraction they are asking, that is also very important. So in that way, what is mole fraction of B? Number of moles of B by number of moles of B plus, number of moles of, from beginning you can write, not a problem. Number of moles of A plus, number of moles of B plus, number of moles of C. This is mole fraction of B. In same manner, you can write what? That mole fraction of mole fraction of C, that is number of moles of C by number of moles of A plus, number of moles of B plus, number of moles of C. Like this you can have. Get it? So these all are very important. Mole fraction of A, mole fraction of B, mole fraction of C, like this. Okay? And one more important thing, sum of the mole fractions. Sum of the mole fractions is always equal to 1. That is, here I will write the mole fraction of A plus mole fraction of B plus mole fraction of C is equal to 1. Sum of the mole fractions of all components is equal to 1. Just add all these 3. This one and this one. Add these 3. This plus this plus this. So denominator is same and numerator will be same. See, Na plus Nb plus Nc. So we'll cancel. So sum of the mole fractions of all components is equal to 1. So this is very, very important for us. And for mole fraction, there is no units, as I told you. Why no units? Here only you have numerator moles, denominator also moles you have. So write down all these things, have a screenshot and write down clearly. Okay, sir? So otherwise, pause it and write down. So very important. So now I'll give you few more examples for mole fraction only. Okay, sir? So let's see. What is a mole fraction of a solution if consists of one solute as solvent? So okay, so if solution consists solute and solvent only. If solution consists only solute and solvent, then what is mole fraction of solute? Solute has number of moles, n solute, and solvent has number of moles, n solvent. Small n means everybody knows, no? N means number of moles. I'll write otherwise. N means what? Number of moles here. What is the mole fraction of a solute? You can write simply X, not a problem. Like this also you can write Xi. Okay. So mole fraction of solute is equals to number of moles of solute by number of moles of solute plus number of moles of solvent. This is what? Mole fraction of a solute. What is this? Mole fraction of solute, this one. What is mole fraction of solute formula? Mole fraction of solute is equals to number of moles of solute by number of moles of solute plus number of moles of solvent. Very important. And same way, what is mole fraction of a solvent? Very simple. Instead of solute, whose moles you will consider? Number of moles of solvent you will consider in numerator. So whose mole fraction you are taking, that for that particular you have to consider number of moles in numerator. That is very important. So what you will consider? Number of moles of solvent by number of moles of solute plus number of moles of solvent. So very important. So this formula also you must know. Mole fraction of solvent is equals to number of moles of solvent by number of moles of solute plus number of moles of solvent. So very important. So you must know all these things. And same way, mole fraction of solute plus mole fraction of solvent is equal to 1. Just add these two. You only will have. What do you have in the denominator? In both cases. What do you have? Denominator. Number of moles of solute plus number of moles of solvent you have, right? And numerator here what you have? For mole fraction of solute. So number of moles of solute you have plus number of moles of solvent you have. So what you can write finally? Mole fraction of solute plus mole fraction of solvent is equal to 1, you can say. Mole fraction of solute plus mole fraction of solvent is equal to what, sir? 1. Got it clearly? So very important. This is about the mole fraction, and we will see some numericals based on this mole fraction. So have a look, and this is mole fraction of solute and this is mole fraction of solvent. So if solution consists of both solute and solvent, so you will have only two mole fractions. One is mole fraction of solute and another is mole fraction of solvent you will have. That's it. Okay. So I will tell you here. If solution consists of some 4 grams of NaOH in some 9 grams of water, then what is mole fraction of a solute and what is mole fraction of solvent? These are the questions. Okay, so 4 grams of NaOH is present in 9 grams of water. Certainly the sodium hydroxide is dissolving, so sodium hydroxide is a solute for us. Who is solute? NaOH is a solute for us. So what is the mole fraction of solute? That means mole fraction of NaOH only is nothing but mole fraction of solute. So what is the formula? Number of moles of NaOH by number of moles of NaOH plus number of moles of Mr. water. So this is a formula we have to use. Mole fraction of NaOH. Who is NaOH here? So this NaOH only called solute. So mole fraction of solute is equals to number of moles of that NaOH, because NaOH is a solute, and number of moles of NaOH plus number of moles of water. So how you will have number of moles of this? Number of moles of NaOH, how you will have, sir? Number of moles of NaOH is equals to the weight of solute by that gram molecular weight, right? That means it is just 4 by 40. 4 by 40 here. So it's 0.1 moles. Same way, number of moles of water. So it's a same story. Weight of water. So he given 9. Weight of solute given 4 grams. 4 by 40. Because sodium hydroxide weight is 40. Okay. 40 is what? Molecular weight. Gram molecular weight of sodium hydroxide. I was given gram molecular weights. Sodium 23, oxygen 16, hydrogen 1. Got it clearly? So 4 by 40. You will have 0.1. So number of moles of Mr. NaOH, how many? Means 0.1. Same way number of moles of water you will have. Same story. Weight by weight of water here. Because whose moles you are considering? Water. So water how many grams given? 9 grams by gram molecular weight. So it will be number of moles of water. It's 9 by 18. 18 is the gram molecular weight of water. So 9 by 18. So it's 1 by 2. 1 by 2 means number of moles of water. You will have 0.5. So number of moles of NaOH you have and number of moles of water you have, right? So what is the mole fraction of NaOH, which is called solute, because that is dissolved, that was dissolved. Okay, so mole fraction of solute is equal to 0.1 by 0.1 plus 0.5. Very clear? So mole fraction of NaOH, it is 0.1 by 0.6, that means 1 by 6. Okay, so mole fraction of NaOH is 1 by 6. Understood or not? So it's 0.1. Okay, and 4 means how much? 6 6 zeros, 6 7 okay, no 6 6 so 0.16, that's it. Mole fraction of NaOH how much? Mole fraction of NaOH is 1 by 6. 1 by 6 means 0.16 something. No units, because mole fraction means number of moles to the total number of moles. What is the mole fraction of solvent? Who is solvent there? Water. Mole fraction of solvent is equal to, you can use 1 minus mole fraction of solute. You have no need to do again like this. You know a relation. Simply, what you know relation? Mole fraction of solute plus mole fraction of solvent is equal to 1. Do you know this relation? Mole fraction of solute plus mole fraction of solvent is equal to 1. So mole fraction of solute, you know, 0.16, and mole fraction of solvent. Okay, so mole fraction of solvent. Who is solvent here? Who is solvent? Here solvent means water. So mole fraction of water here 1 minus 0.16. Otherwise 1 minus 1 by 6. You should just take that, not a problem. Getting? Hello. Okay. So this is mole fraction of a solvent. Mole fraction of solute you have and mole fraction of solvent you have like this. So these all are very very important for us. Just have a look, and few more numericals we will do in our next class. Thank you.